calculate voltage drop for a general purpose receptacle, you will use a specific formula. That formula is voltage drop equals current in amps multiplied by the length of the wire in feet, then multiplied by the resistance of the wire in ohms per foot. Firstly, determine the current in amps. For a standard general-purpose receptacle, the typical current draw used for voltage drop calculations is 15 amps. This is based on the assumption that the receptacle might be used to power a device drawing close to the maximum allowable current. Secondly, measure the length of the wire. This is the total length of the wire from the electrical panel or source to the location of the receptacle. You need to account for the entire run, including any bends or turns in the wire's path. Thirdly, find the resistance of the wire. The resistance of the wire in ohms per foot depends on the wire gauge and the material is made of, typically copper or aluminum. This information can be found in wire specifications tables provided by wire manufacturers or in electrical codes. For example, 14-gauge copper wire has a different resistance per foot than 12-gauge or 10-gauge wire. The resistance also varies with temperature, but for most calculations, a standard operating temperature is assumed. Once you have these three values, you can plug them into the voltage drop formula. Let's illustrate this with an example. Suppose you have a 100-foot run of 14-gauge copper wire feeding a general-purpose receptacle. The current is 15 amps, and the resistance of 14-gauge copper wire is approximately 0.4 ohms per foot. Using the formula, voltage drop equals 15 amps multiplied by 100 feet multiplied by 0.4 ohms per foot, which equals 6 volts. This means that the voltage at the receptacle will be 6 volts less than the voltage at the source, such as the electrical panel. It's essential to ensure that the voltage drop does not exceed the allowable limits specified by electrical codes and standards. Excessive voltage drop can cause appliances and equipment to malfunction, overheat, or operate inefficiently. For branch circuits, a common recommendation is to limit the voltage drop to no more than 3%. If the calculated voltage drop is too high, you can take several steps to reduce it. Firstly, you can increase the wire gauge. A larger wire gauge has a lower resistance per foot, which reduces the voltage drop. Secondly, you can shorten the length of the wire run. By reducing the distance between the source and the receptacle, you decrease the overall resistance of the wire. Thirdly, you can reduce the current. Although this is not always practical, if the load on the receptacle is less than 15 amps, you can use that lower value for the voltage drop calculation. However, it's essential to consider the potential for future loads that may draw the full 15 amps. The National Electrical Code, or NEC, provides guidelines and tables for calculating voltage drop and selecting appropriate wire sizes. It's important to consult the NEC and local electrical codes to ensure compliance with safety standards. For instance, NEC Section 210.19 A1 Informational Note Number 4 recommends a maximum voltage drop of 3% for branch circuits and 5% for feeders plus branch circuits. This is only a recommendation and not a hard requirement. The voltage drop formula presented is a simplified version that assumes a purely resistive circuit. In reality, electrical circuits may also have inductive and capacitive components, which can affect the voltage drop. However, for most general-purpose receptacle circuits, the resistive component is dominant, and the simplified formula provides a reasonably accurate estimate. In addition to the voltage drop calculation, it's crucial to consider other factors when designing electrical circuits, such as ampacity, which is the current carrying capacity of the wire, and overcurrent protection, which is provided by circuit breakers or fuses. The wire gauge must be large enough to handle the expected current without overheating, and the overcurrent protection must be sized appropriately to protect the wire from damage in case of a short circuit or overload. When selecting wire for a general-purpose receptacle circuit, it's important to consider the ambient temperature in which the wire will be installed. High temperatures can reduce the ampacity of the wire, so it may be necessary to use a larger wire gauge in high-temperature environments. Also, the type of insulation on the wire affects its ampacity rating. Different types of insulation are rated for different maximum operating temperatures. It is vital to ensure proper connections when wiring receptacles. Loose or corroded connections can increase resistance, which leads to increased voltage drop and potential overheating. Use appropriate connectors and ensure that they are properly tightened. When calculating voltage drop, it is crucial to use consistent units. If the length of the wire is measured in feet, the resistance must be expressed in ohms per foot. If the length is measured in meters, the resistance must be expressed in ohms per meter. Always double-check your units to avoid errors in the calculation. Here's a more detailed explanation of how to find the resistance of the wire. Wire manufacturers typically provide tables or specifications that list the resistance per foot or per meter for different wire gauges and materials. These tables are usually based on standard operating temperatures, such as 20 degrees Celsius or 68 degrees Fahrenheit. The resistance of the wire increases with temperature, so if the wire is operating at a higher temperature, you may need to adjust the resistance value accordingly. The resistance of copper wire is generally lower than the resistance of aluminum wire for the same gauge and length. This is why copper wire is often preferred for electrical wiring, especially in applications where voltage drop is a concern. However, aluminum wire is lighter and less expensive than copper wire, so it may be used in some applications such as overhead power lines. When using aluminum wire, it's important to use connectors and terminals that are specifically designed for aluminum wire to prevent corrosion and ensure a reliable connection. Corrosion can increase resistance, leading to increased voltage drop and potential overheating. In addition to using the voltage drop formula, you can also use voltage drop calculators, which are available online or as mobile apps. These calculators can simplify the calculation process and help you quickly determine the voltage drop for different wire gauges, lengths, and currents. However, it's essential to understand the principles behind the voltage drop calculation and to verify the results of the calculator to ensure accuracy. When working with electrical wiring, it's crucial to follow all safety precautions and to comply with all applicable electrical codes and standards. If you're not comfortable working with electricity, it's best to hire a qualified electrician to do the work. Electricity can be dangerous, and improper wiring can lead to electric shock, fire, or other hazards. Before starting any electrical work, always turn off the power to the circuit at the electrical panel and verify that the circuit is energized using a voltage tester. Wear appropriate personal protective equipment, such as safety glasses and insulated gloves. Never work on live electrical circuits. Also, remember that electrical codes and standards can vary depending on your location, so it's essential to consult the local authorities or a qualified electrician to ensure compliance. Another consideration when calculating voltage drop is the type of load that the receptacle will be serving. Some loads, such as motors, may draw a higher current when they start up than when they are running continuously. This inrush current can cause a temporary voltage drop, which can affect the performance of the motor. In such cases, it may be necessary to use a larger wire gauge to minimize the voltage drop during startup. Furthermore, it's important to consider the cumulative voltage drop in a circuit. If a circuit has multiple receptacles or loads connected in series, the voltage drop will increase along the circuit. The voltage at the last receptacle in the circuit will be lower than the voltage at the first receptacle. It's essential to ensure that the voltage at all receptacles in the circuit is within the allowable limit. When calculating the cumulative voltage drop, you need to consider the current drawn by each load and the length of the wire between each load. The voltage drop at each section of the circuit can be calculated separately, and then the total voltage drop can be determined by adding the voltage drops at each section. In some cases, it may be necessary to use a larger wire gauge for the entire circuit to minimize the cumulative voltage drop. Alternatively, you can divide the circuit into multiple smaller circuits, each with its own dedicated wire run. This can help to reduce the voltage drop and improve the performance of the loads. Another factor to consider is the grounding of the electrical system. A properly grounded electrical system is essential for safety and to prevent electrical shock hazards. The grounding conductor provides a low impedance path for fault current to flow back to the source, which causes the circuit breaker to trip and energize the circuit. The grounding conductor should be sized appropriately to handle the expected fault current. The size of the grounding conductor is typically based on the size of the ungrounded conductors in the circuit. The NEC provides tables that specify the minimum size of the grounding conductor for different wire sizes. In addition to the grounding conductor, it's also important to ensure that all metal enclosures and equipment are properly bonded together. Bonding creates a low impedance path for fault current to flow between different metal parts, which reduces the risk of electric shock. Bonding is typically accomplished by connecting all metal parts together using bonding jumpers or bonding screws. The bonding jumpers and screws should be sized appropriately to handle the expected fault current. The NEC provides guidelines for bonding electrical systems. When working with electrical wiring, it's essential to use proper wiring techniques and to follow all applicable electrical codes and standards. Improper wiring can create safety hazards and can lead to electrical shock, fire, or other problems. If you're not sure how to do something, it's best to consult a qualified electrician. Electricity is a powerful force, and it's important to treat it with respect. Always take the necessary precautions to protect yourself and others from electrical hazards. Remember that voltage drop calculations are just one aspect of electrical system design. There are many other factors to consider, such as ampacity, overcurrent protection, grounding, and bonding. It's important to have a thorough understanding of electrical principles and to follow all applicable codes and standards to ensure a safe and reliable electrical system. Let's consider a situation where you are dealing with a very long wire run, for example, 200 feet, using 12-gauge copper wire for a 15-amp general-purpose receptacle. The resistance of 12-gauge copper wire is approximately 0.159 ohms per foot. The voltage drop would be calculated as follows: voltage drop equals 15 amps multiplied by 200 feet multiplied by 0.159 ohms per foot equals 4.77 volts. If the source voltage is 120 volts, the voltage at the receptacle would be 120 volts minus 4.77 volts equals 115.23 volts. This voltage is within the acceptable range, as it's generally recommended to keep voltage drop below 3%, which in this case would be 3.6 volts. However, if the wire run were even longer, or if the load were higher, the voltage drop could exceed the acceptable limit. In such cases, you would need to increase the wire gauge or take other measures to reduce the voltage drop. Another scenario to consider is when you have multiple receptacles on the same circuit. In this case, you need to calculate the voltage drop to each receptacle, taking into account the current drawn by each load and the length of the wire to each receptacle. For example, suppose you have two receptacles on a 100-foot run of 14-gauge copper wire. The first receptacle is located 50 feet from the source, and the second receptacle is located 100 feet from the source. The first receptacle is serving a load that draws 10 amps, and the second receptacle is serving a load that draws 5 amps. The voltage drop to the first receptacle would be calculated as follows: voltage drop equals 10 amps multiplied by 50 feet multiplied by 0.4 ohms per foot equals 2 volts. The voltage drop to the second receptacle would be calculated as follows. Firstly, you calculate the voltage drop due to the first load by using the equation 10 amps multiplied by 100 feet multiplied by 0.4 ohms per foot equals 4 volts. Secondly, you calculate the voltage drop due to the second load by using the equation 5 amps multiplied by 50 feet multiplied by 0.4 ohms per foot equals 1 volt. Thirdly, add these voltage drops together. 4 volts plus 1 volt equals 5 volts. The voltage at the first receptacle would be 120 volts minus 2 volts equals 118 volts. The voltage at the second receptacle would be 120 volts minus 5 volts equals 115 volts. Again, these voltages are within the acceptable range, but it's important to check the voltage drop to each receptacle to ensure that it's within the limits. Another consideration is the use of different types of wiring methods. For example, you may be using conduit, cable, or open wiring. The wiring method can affect the ampacity of the wire and the voltage drop. Conduit can provide additional protection for the wire, but it can also increase the temperature of the wire, which can reduce its ampacity. Cable may be easier to install than conduit, but it may not provide as much protection. Open wiring is typically used only in industrial or agricultural settings where it's not exposed to physical damage. It is crucial to select the appropriate wiring method for the application and to follow all applicable codes and standards. Furthermore, remember that voltage drop is not the only factor to consider when designing an electrical system. You also need to consider the ampacity of the wire, the overcurrent protection, the grounding, and the bonding. All of these factors are important for ensuring a safe and reliable electrical system. When calculating voltage drop, always use accurate measurements and reliable data. If you're not sure about something, it's best to consult a qualified electrician. Electricity is a powerful force, and it's important to treat it with respect. By following these guidelines, you can safely and effectively calculate voltage drop for general purpose receptacles and ensure that your electrical systems are safe and reliable.